The first figures, or at least the first figure to the right here, takes 5 matchstick squares to build. The second one takes 9 to build. And the third one takes 13 to build. So let's answer the first following question. How many matchsticks squares will it take to build the 12th figure? Well, to determine how many matchstick squares it will take to build the 12th figure, we're going to use the first few figures to find a pattern. Now note that 4 squares were added to the first figure to obtain the second figure. Also, there were 4 squares added to the second figure to obtain the third figure. Now we're going to sketch the next figure in the sequence to determine how many squares were added to the third figure to obtain the fourth figure. Now again, 4 squares were added. So the number of squares is increasing by 4 each time. And then using this pattern, we want to write the expanded form from the number of squares it takes to build each figure. So here is so if we look at the third one, then this becomes the fourth one. So what we're doing is we're adding 4 more squares. So here's our figure number. So the first figure has how many number of squares? Well, it has 5 squares. For the second figure, we have 5 plus 4. So the second figure has 5 plus 4. The third figure is 5 plus 2 times 4. And then now the fourth figure is 5 plus 3 times 4, which is 12. Therefore, use the pattern to determine the number of squares it takes to build the 12th figure. Well, it would take 5. Okay, well, if you look here, 3 minus 1 is 2. 4 minus 1 is 3. So if we want to find the 12th figure, it's going to be 5 plus, well, 12 minus 1 is 11 times 4, which is equal to 49 squares to build the 12th figure. Okay, now next it says, how many matchstick squares will it take to build the nth figure? Well, we're going to use the table to help write the pattern for the nth figure. Okay, so we know that the figure number 1, the number of squares is 5. Figure number 2, we know it's 5 plus 4. Figure number 3 is 5 plus 2 times 4. Figure number 4 is 5 plus 3 times 4. And now with 12, we know it's 5 plus 11 times 4. That means that whatever n is, it's going to be 5 plus, to get this number, it's going to be n minus 1 times 4. So simplifying gives us the following. So we're going to take 4 and then we're going to distribute it to those two terms. So 4 times n is going to give us 4n, and 4 times minus 1 is minus 4. So we get 5 plus 4n minus 4, and now we combine like terms. We have 4n, and 5 minus 4 is 1, so therefore we get the nth to be 4n plus 1. So we would say it will take 4n plus 1 squares to build the nth figure. Now, how many matchsticks will it take to build the nth figure? Well, to determine the number of matchsticks required to build the nth figure, it may seem natural to multiply the number of sides in a square 4 by the number of squares for n plus 1. However, notice that even for the first figure, this reasoning does not give the correct result. The first figure has 5 squares, but only requires 16 matchsticks to build, not 20. This is because some of the squares share a side. That is, one matchstick can be a side in 2 different squares. Another method must be found. So therefore, there are many strategies for counting them. So here we will count the vertical matchsticks and horizontal matchsticks and then add. So now what we're going to do is we're going to create another table for the number of matchsticks themselves. Okay, so let's take a look here. So if we take figure number 1, what is the number of vertical? Well, we have 8. Okay, so let's take a look at that. I'm going to bring this down here so you can see the pictures. Okay, so if we look at figure number 1, how many do we have that are going vertical? We have 1, 2, 3, 4, 5, 6, 7, 8. The number of horizontal is 1, 2, 3, 4, 5, 6, 7, 8. The total number of matchsticks is 16. Okay, next, figure number 2, how many vertical matchsticks do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then how many do we have the number that are horizontal? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. When we add up the amount of matchsticks, we get 26. For 3, we should have 20 that are vertical, and we have 16 that are horizontal, so 20 plus 16 is 36. So it says the number of vertical and horizontal matchsticks has been added. So we want to find a pattern using the shaded column. So if you take a look here and here, right, here's our number figure, right? Here's the total number of matchsticks. So again, the pattern is of repeated adding in arithmetic sequence. So recall that the formula for the nth term of an arithmetic sequence is the following. We have a subscript n, which is equal to the first term, plus n minus 1 times the common difference. Okay, so in this case, the initial number of matchsticks is 16. And then if you look, in each subsequent figure requires 10 more matchsticks in that last figure. So we want to write a formula for the number of matchsticks it will take to build the nth figure. So if we take a look at our formula, we know 16 is the first term, 10 is the common difference. Let's distribute the 10. And we get 10n minus 10 plus 16. So combining like terms, we end up getting 10n plus 6.